everyone, welcome once again to my YouTube channel. In this video, we will see how to delete non-English app using ASCII code, and we'll also separate the free apps from the non-free apps.
Now, we'll delete the non-English apps based on the track name colon. We'll be checking it based on ASCII code to determine if it is an English app or a non-English app.
So now we are back to our Clean App Store module. The Clean App Store module is responsible for deleting duplicates, removing non-English app, and separating free from non-free apps. So we finished explaining what the highest duplicate module does. Now we are going to the non-English function or module. That's the non-English app module that contains the non-English function. So let's see how the operation was carried out. So here we are. Now what this module does is it checks the name of each app and checks if the name is an English name or a non-English name. And how it does that, it uses ASCII character. So it checks for ASCII character greater than 127. Now, what is ASCII? ASCII code is a code or numbers given to characters. And for English characters is less than 127 downwards. Anything above 127, number 127 is a non-English character. So it checks each character in the track name and checks, is this a English character? If it's not an English character, automatically that app is not an English app. But now I had to do something. I had to check to make sure. I said the ASCII character, if they are more than 2, then you should declare that app as a non-English app. Why did I do this? Because there are some apps that contains characters that are non-English. For example, an emoji or a trademark. Now, let's go back to the original data set so you can understand what I'm saying. Now, this is the data set here. We have this name here that I colored yellow. This is a Chinese app and it contains 3 characters. Now, this is an English app, City Mobile, with green here. You can see the trademark R, that R in circle. So when the ASCII is reading it, it will not see it as an English character. So if I didn't give room for 2, it will delete this City Mobile, this green one, it will delete it also. And that will reduce the integrity of our result. Now, the reason why I made it 2, I didn't make it up to 3, is because you can see this is an obvious Chinese character in this yellow box here. And it contains just 3 characters. So that is why I didn't make it more than 3. I just put it 2. 2 to give room for people, names like this, the City Mobile, and also not to include the Chinese character with like this one that has only 3 characters. So now let's go to the code. So now we say non-ASCII equal to 0. Non-ASCII equal to 0. We are declaring it, we are initializing it as 0. That is a container that is empty with just 0 elements for now. Anytime you want to do sum, you want to sum something, you initialize it to 0 first. So we now come and now say for row in app name. Take note, I had to declare the app name as str. Now, if you want to declare a value to be string, that is, it has characters, name, and you use the str keyword or function, and it makes the app names as string. Because when I ran the code initially without using str, it was giving an error saying you are trying to iterate through a float value and it can't. So it means there are some names that are just numbers and there can be issues. So I had to declare that column as string for it to work that way. So it now says for character in the row, When it picks the row, it checks the row and says, okay, what is in this row? Each character of the name, it's as first and foremost, the first for loops picks the name on each row. This second for loops now loops through each character of the name to check if each characters are English character or non-English character. Then this ORD function is the ASCII function that checks each character. So it picks one character and checks. If odd is greater than 1 to 7, then increase the value non-ASCII. It now says non-ASCII plus 1. Don't forget the initial non-ASCII was 0. It will now be 0 plus 1. So the new non-ASCII will now be 1. If it iterates through again, picks the second character, and it is greater than 1 to 7, the non-ASCII, which is 1, will now become 1 plus 1. The non-ASCII will now become 2. It will continue to count like that until it finishes looping through each character of that name it has picked. When you finish looping through each character of that name it has picked, you will pick the second name, do the same thing, and check. So now we'll now check. If the non-ASCII is greater than 2, return true. It means, the true means it is a non-English app. Else, return false. Return false means it is a English app. Return true means it is a non-English app. While return false means it is a English. Now, for us to understand what was passed in as the app name here, what was passed in as the app name here is just the track name column. For you to understand this, let's go back to where we are coming from, the Clean App Store. The Clean App Store is the function that carried out the delete duplicates, remove non-English app, and separate. Now we look at the function that did the removing of duplicates. We said the result of the removing of duplicate should be put in the function df. So this new df now is what was passed into this non-English function. So this non-English function contains the table that has only the unique values with maximum rating. So it was passed into this function. What's the name of the function? Non-English function. Now let's go to the non-English function. Now here is the non-English function with the data frame, the table passed into it. So it says English app, we create a list container. We now say for app in that table that we passed in, check the app name. You know, app name is the track name. Check the app name. If is English. Now, what is English? Is English is this function here. Is English. That is the function. So we are now calling this function into this function. We are now saying check if is English. So we passed in app name. And what is app name? This is app name, which is the track name column. So we passed in the track name column to check if is English. So if is English is false, that means it is a English app. Then you append that name, that row, you append that row into this list container called English apps. Append means put that app into this container. Don't forget, for app in this table, let's check, is that name a English name? If it is an English name, which is the meaning of false, put that app and its details into this container, this list. So once it puts it into this list, so it will go through the whole table and put only the English apps into this list, this container. So after putting everything into the list, I now converted that list to a data frame. So that's what this line of code is, pd.dataFrame. So it converted this English app list to a data frame and named that data frame df English. So we returned the table df English. So that table that we are returning now, so anytime you call non-English, the table that you'll be calling is a table that doesn't have duplicates, only unique value with maximum rating, which we also remove the non-English app. So that is what is contained in the non-English function whenever you call it. So let's go back to our Clean App Store table.
Now, we'll separate the free from non-free apps using the price colon.
So now we are in our Clean App Store function or module. So now the next one, after the duplicate, the non-English, now we're looking at the final one, separating the free from non-free. Now this df is the result from the non-English function is put in here. So that's the df we are passing into this price separate. This price separate is located in the free app module. So now let's go to the free app module to see how it was carried out. So here we are in the free app module. So what we did, the function price separate, we created an empty list container for free apps and we created an empty list container for non-free apps. So we iterate through that table df. We say for app in df, check the price column. Now app.price means locate the price column and let's name it price. So anytime you see the name price, you know we are referring to the price column. We now say if price is 0.0, if you go through the data set, the price are put in 0.00 or 3 points, you understand? So if the price is 0.00, then put that app into the free app container. That is what this line of code does. Else, put the app in non-free app container. So after doing that, we now converted the containers, the free app container and the non-free app container, to a data frame. So that is what df free means, converting the free app to a data frame, that is table format, and the df non-free converted the non-free list to a data frame, to a table. Then I commented out this section. What this section does, write the apps to a file, df_free.tocsv. What it does is it now puts the result, the table, into a CSV file and names the CSV file free_apps.csv. free_apps.csv. So that is what it does. And you put this encoding UTF, that's the coding, how it should be encoded. And we say false, that is, don't effect changes, just put it the way it is into the CSV file. So that is what tocsv does here. So now we are returning two values. Take note of the return statement. We are having two values here, and the two values are put in a list container. Don't forget your square bracket is a list container. And when you are referencing a list, the first value in the list is 0 and the second is 1, and so on and so forth. So we are returning the free apps and the non-free apps table. So anytime you call the price separate function, which is located in the free app module, you are going to be having two values in them. And the first value is the free app table and the second value is the non-free app table.
In our next video, we will determine the percentage of each app gen, we will calculate the average rating of each app gen, we will explain the result of our analysis, and we will give recommendation based on the result of our analysis.